Good afternoon, ladies and gentlemen. Welcome to the now I have to wait till the phone stops ringing in my head. Welcome to the March Badger Forum. Today we're talking about global warming. We have two distinguished speakers who will take dissimilar sides of the issue. The order of presentation was determined by a flip of a coin, witnessed by both speakers and our president, Mark Harden, a few minutes ago. So let me introduce first Chuck Long, who earned his doctorate in meteorology from Penn State University. He's currently site scientist for the Department of Energy's Atmospheric Radiation Measurement Program based at Pacific Northwest National Lab. Dr. Long specializes in the study of clouds and their effect on surface radiation energy balance of the Earth-atmosphere balance. His areas of research interest include clouds and atmospheric radiation, radiative transfer, observational analysis, and instrument development. Each of the speakers has a PowerPoint presentation. My apologies up front for whatever damage I did to your reputation in introducing you. But let me introduce Chuck Long, and I will join him at the wireless microphone and make the pictures appear on the screen. Chuck?
There you are, sir. Okay, well, hope you enjoyed your meal. Hope you didn't eat too much. Hope all the blood didn't go to your stomach and you have some left over for your head, because I'm sure you're going to need it. As he said, by trade I am an atmospheric science researcher, and as such I want to be precise about what exactly we're going to be talking about here today, because what we're going to be discussing is whether human activity is actually influencing the climate, not just climate warming. I mean, the climate has warmed and cooled in the past. That's obvious in the geologic record. The question is really whether human activity is influencing this. And I do want to point out here, very important, that we're talking about global warming. As you'll see in a minute, that is an important thing to find out. Climate information, well, I'm sure you know there's a lot of it out there. You can Google all kinds of things. Unfortunately, you also find out when you're in my trade that there's a lot of it that's poor information out there. And that has caused a lot of confusion about this issue. Atmospheric science is a complicated thing. The Earth-atmosphere system is not a simple thing to try and understand, and so you can't really understand it by cruising the internet for a half hour, and I can't explain it all to you in 10 minutes. So what I'm going to do here today is give you two examples of some of the misinformed arguments that you'll run into out there, and try and show you how lack of understanding of the system can lead you down the wrong path. To do this, I've actually, in honor of Mike, pulled two examples out of his Falsifying the Global Warming Hypothesis article that was published in the Hawaii Reporter in January. And Mike is listed as a science and energy resource for the Hawaii Reporter. The first is Mike mentions that water vapor is the most abundant greenhouse gas that we have in the atmosphere, and this is true. However, he says it's usually ignored in the global warming hypothesis for unexplained reasons, and that this presents a major problem for the theory of anthropogenic global warming. Well, this is a little disturbing to me, because it suggests that either atmospheric scientists as a whole never thought of this, or we did think of it, and for some unexplained reason we're trying to keep it a secret. And so this question sounds awful damning. Well, in reality, there is no secret. The concept is the constant relative humidity concept that has been, frankly, in every single global climate model for at least the past 30 years. To understand it, well, what is this thing called relative humidity? Relative to what? It's relative to temperature. If you increase the temperature, then in order to maintain a constant relative humidity, you have to add more water vapor to the atmosphere. So the way this works with reference to global warming is, if you add greenhouse gases other than water vapor to the atmosphere, greenhouse warming will raise the temperature. Once the temperature raised, the system adjusts by adding more water vapor which, yes, we know is a greenhouse gas, in order to maintain the constant relative humidity. So now you have more greenhouse gases, more greenhouse warming, and it actually increases the temperature again. This is a very well understood, very well known, very basic, what we call a water vapor feedback mechanism. I mean, it's really basic to our understanding of this. If you actually read the IPCC reports even, you will read in there that half to two-thirds of the predicted warming actually comes from the water vapor due to this water vapor feedback mechanism. So it's not a secret. It is in there. And, you know, frankly, it has been published literally hundreds of times in the past couple of decades. If you do a Google Scholar search for either constant relative humidity or water vapor feedback, you will get a list of literally hundreds of papers that have discussed this topic. So it certainly is no secret, and it certainly has been included in all of our discussions, theorizations, and predictions. It is common knowledge in the atmospheric science community, and so to suggest that it isn't in there for mysterious reasons really is showing that there's a little lack of understanding of this whole system that we're dealing with. The other example comes from a chart that was put together by Dr. Willie Soon of the Department of Astrophysics at Harvard from his article entitled "It's the Sun, Stupid." And in here, he basically makes some comments about that it is solar radiation that is causing this thing. I do note that at the bottom of this, there's a disclaimer that this is Dr. Soon's own opinion. Apparently, Harvard University wants that known. From the article in the Hawaii Reporter, with reference to the chart, the first point that's made is there is little correlation between fossil energy use and global temperatures. Well, from the get-go, this is a misinterpretation because the chart itself clearly says Arctic air temperature, not global air temperature. You cannot take some small temperature record from someplace on the globe and relate that directly to what's going on globally. You cannot look at the temperature record from Spokane, Washington, or someplace in the Arctic and infer globally. You have to literally infer from the global analysis, because no one expects with global warming all temperatures to increase exactly the same amount everywhere. It's a complicated system. Some places are actually going to get cooler. We know this. But a lot more places are going to get warmer. So you have to work in global numbers and in global terms if you're going to talk about global warming. The other thing is 2 points about the plot itself. This thing labeled Arctic air temperature just does not match other published temperatures from places like NOAA or the UK Hadley Center, and they all show a much steeper increase in temperatures for the Arctic being everything above the Arctic Circle. But if you're going to try and make a point about global warming, one wonders why Dr. Soon did not use the global temperature record, which also shows a much steeper temperature rise in the last 30 years than the temperatures he's plotting here. Finally, the solar record that he's using does not match the solar activity or energy output of the sun from such places as the World Radiation Data Center in Davos, Switzerland, NOAA, the Max Planck Institute in Germany. They show that in the last 30 to 50 years, there has been no significant trend in either solar activity or solar energy output. And this is, so the whole plot, not only the Arctic temperatures plotted, but the solar activity is in disagreement with peer-reviewed published results.